Hi, I'm Alan. I'm an engineer at Protocol Labs, and this talk is about NFTs and the off-chain side of them and how they can be stored decentralized on IPFS and Filecoin for a long time, for the long haul. So I'm kind of new to NFTs. I guess we kind of all are really. When I found out about them and I started getting interested, I was really happy to see that IPFS was already being used to store them, working for Protocol Labs and having worked on IPFS quite a bit. It's really nice to see it being used in the wild. So for example, I can just pull up any kind of NFT marketplace, for instance, just this one, check on activity, and wow, look at that. So this is just like NFTs that have been created or bought quite recently. And if I click through, I can just have a look down, hopefully down here. And if I click through to view transaction on Etherscan and then do a little bit of spelunking in the Ethereum blockchain, pull up the contract, whoosh, scroll down here, put that in there, do a query, and look, hey, it's an IPFS. This is an IPFS hash. Hey, rad. Okay, so and then I can literally just put that in my browser, and this comes up as in my browser here, and I can just click through to see that NFT in all its high res glory. So fun times. All right. So back to the slides. Where are we? Why are these NFTs stored on IPFS? Well, first of all, it's kind of prohibitively expensive to store big data like that on chain in Ethereum, at least. And IPFS has some really nice properties for off-chain data that we can get into in a little bit. But yeah, that's super rad. So anyway, as I learned a little bit more about NFTs, I came to realize that the developers enabling NFT creators, so these are kind of NFT marketplaces like Foundation, like Super Rare, like Zora, they really cared about users being able to access their data should they ever disappear. So if they just went poof, they didn't want all of these fantastic NFTs to just fade away, because they're NFTs. They're things that they're artwork that people have created, that people have bought, and they shouldn't just disappear into nothingness. So that would suck. So IPFS can solve this problem and actually fits this bill really well. So it's not all that surprising that it's being used already. But in case you're kind of new to IPFS, let me explain by going over a few basics. Okay, so I've got this random NFT that I found, a picture of some mountains that is some sort of generated. It's really pretty. I love it. I'm going to put this data in my IPFS node. So for example, if I put this NFT, if I import it into my IPFS node, then I get back a CID, which stands for content identifier. And CIDs are a kind of cryptographic hash, and they address the content, not its location. So that means that any given CID will always refer to that same piece of content. Or if we flip it round to a different way, if the content changes, then the CID would have to change as well. And so the idea is that once you've got the CID, or what typically happens is that that CID or a URL to a gateway, an IPFS gateway with that CID in it is what's stored on chain. But if that wasn't stored on chain and just a regular URL to any old website, any old like Google Drive or whatever, then that could be problematic. And that's problematic potentially because like the owner of that content could just delete it. Or like the domain could expire, and or like the hosting could expire and never renewed, and then the NFT will be lost forever, or possibly even worse, you could, like that NFT could be altered. So you might have this fantastic image of a kitten, a crypto kitty perhaps, that you've bought, and then whoever owned that perhaps came along and defaced it and made it into a dog, a crypto doggy. Perhaps, and that would not be cool for you. You'd be pretty angry. So that's not good. Another good reason is that maybe this URL is just not accessible from within your country or within your workplace. Maybe you actually need a peer that is actually a bit closer to you to be able to serve it, because you literally just can't request stuff outside of that boundary. Okay, so how does that work? Well, I have that content. I've imported it into my IPFS node. If someone else requests that data by its CID, then they'll receive it. The IPFS network is such that you will search the network and eventually find someone that has it, and then try and connect to them. And when you have connected to them, you'll receive that data. And so now 2 nodes can serve that content, which is super cool. And so kind of like this, so a 3rd node comes along and asks for the CID, but both of those nodes can now serve that request and send that data to that 3rd node. That's cool. And what it means is that this original node can actually just go away. So gone. And that data will still be retrievable from the other nodes. And so this is the awesome power of peer-to-peer networking. You might have heard of it. All right, caveats. Yes, there's 2 caveats. Okay, the first one is kind of interesting, but and kind of obvious. But if all of the nodes that have that content like go away, if they're simply not available, then there's no one to serve that content to you. So you can't get it. There's no way. So that's the kind of obvious caveat. The second caveat is garbage collection. So we have this thing in IPFS called garbage collection, and depending on your configured garbage collection rules, it might run at like a certain time. It might run when your configured repo storage limit is hit. Maybe you've just been IPFS catting loads of data and you've used like a terabyte of data, and IPFS eventually goes, okay, that's the limit hit. Let's do a GC round, and it will just do that. Or it can be run manually. So you can actually invoke IPFS GC from the command line, or you can, if you've exposed the HTTP API, you can hit it over HTTP and tell it to do a GC. So yeah, if you add stuff to IPFS, then it will stay there and it's not eligible for GC. But if you just try and get stuff from the wider network and pull it in, then it's not automatically it doesn't automatically become ineligible for garbage collection. So what you need to do is tell IPFS that the content is not garbage and it's a super rare NFT and it's not trash, it shouldn't be thrown away. And in IPFS, that's referred to as pinning. If you don't pin the data, then it will eventually be garbage collected. So what that means is that even if the content is super, super popular, then it can still eventually exit the network, because well, either nodes could just disappear who have that content, or nodes who did have that content might slowly garbage collect and eventually nobody has it. and that's bad. And then so in general, these 2 caveats are why developers use a third-party service like Pinata, like Textile, like Bleak to store their content. And the reason is that these services actually have nodes that are publicly available and they stay online 24/7. And obviously they pin the content so it doesn't disappear, it doesn't get garbage collected. Cool, so that's caveat number 2. All right, nft.storage is something that we've been working on, and it's a place where you can store your NFT data decentralized on IPFS and Filecoin, and you can store it safe in the knowledge that it will be there tomorrow, and it hopefully goes some way to solving that permanence problem. And it's free. It's free for as long as we can make it free for, as long as we can keep this thing going. And one of the big parts of it is that things should be easy. So let's check out, how does it work? Well, you upload your NFT data to nft.storage. Simple, right? And then what happens is that nft.storage stores that data on IPFS nodes. Okay, so far so good. But what's different from like a regular pinning service? Well, behind the scenes, nft.storage is actually negotiating deals to store your data with miners on the Filecoin network. And the Filecoin network incentivizes miners to store data, and they get paid to store data. And they also typically get paid for like when data is retrieved. So it's a win-win situation for them. Okay, so why is that good? Well, if nft.storage just goes away, and then all of the like nodes, the IPFS nodes, the nft.storage happens to be pinning to went away, and all of the IPFS nodes who ever fetched that content also went away. So all of the IPFS nodes, they just disappeared for whatever reason. They garbage collect the content, or they just vanished from the network. Then the miners will still have the content. The miners are super incentivized to keep storing the content. They get penalties for stopping storing content before the deal term is finished. You can just think of these miners as just another set of IPFS peers. They are built on the same technology as IPFS, and they've got super strong incentives to continue storing the data. So hooray. We had a public launch for nft.storage a few weeks ago. The URL is nft.storage. .storage is a top-level domain. Who knew? And so you should go take a look. We have a simple HTTP API, and it's expressed as an open API schema. If that doesn't mean anything to you, then I guess you could, well, you should know that it allows us to generate nice documentation websites like this, which is cool because you can just use it from the browser without even doing any code. So that's one of the benefits, at least. There's an official client that we built in JS. It's got some TypeScript types. It's got nice API docs, and we've literally just launched a new metadata API, which should make minting NFTs even easier than it was before. And you'll do that with ERC 1155 compatible metadata. So you'll be following standards at the same time, all the best practices baked in. So that's very cool. This is the GitHub org, so what I wanted to highlight here is that because of this open API schema that we have, you should just be able to generate a client in like any other language. And we were like, yeah, that's great, that's brilliant. But then we were like, well, maybe let's just do that. So we did. So we chose like some of the big languages and just generated some clients with tools that we found on the internet. So they might be a bit clunky. It's a machine built them. They might, I don't know, your mileage may vary. But if you are using that, then if you're using one of these, then like let me know. Or if there's problems, then open an issue, open a PR. I'd be really interested to hear from people who are using one of these generated clients, see what their experience is. So, okay, that's that bit of the talk. All right, so I'm going to do a little demo of the JS client to show you what it's like to store NFT data on IPFS and Filecoin. So here we go. This is live coding, so this could go all completely and utterly wrong, but we're going to give it a go anyway. So what I've done is I've installed the client. It's nft.storage on npm. I'm importing a couple of things. So they've got the client. We also got some web APIs that we're exporting as well for use in Node.js, because it doesn't have them natively. But yeah, so this is the default. We don't need to do anything there, but what we do need to do is we need to go and get a token. So let's head on over to the nft.storage website. Okay, so I'm already logged in here. Let's move you out of the way. If I check out my API keys here, I've deleted all my current ones. So I'm just going to create a new one. I'm going to call it demo. I'm going to create the key. Here it is. I will delete this after the demo. So steal my API key. Head over here, paste it in here. Lovely job. All right. So let's talk about this a little bit. All we're doing here is we're instantiating the client, passing it our token. We don't need to pass that, but just there for completeness. And we're going to read a file. This is not the file we're going to read. This is this file. But I put this. Yeah, here we go. We're going to store. This is my favorite. This is my favorite meme on the internet. Hello, yes, this is dog. Just for example processes. Well, let's try storing that. So this, what we're going to call here is the store blob API. This is the simplest API that nft.storage exposes. It just allows you to store raw data and get back a CID that you can use in your minting process if you so please. So what we're going to do is call store blob. So we've read the file, we're creating a new blob because store blob requires a blob to be passed to it. Console log the CID, and then we're going to call the status API, which allows you to check in on the status of a NFT that you've uploaded before. And that means checking out the pin status, see if it's pinned yet or not, and see the size of the thing. But you can also see what Filecoin, like information about Filecoin deals that have been made with this particular CID. You can see like which miners have your data and what the current status of that deal process is. Cool. Okay, so I'm going to save this, and in theory, this should be good to run. Yes, this is dog. This is good. So I'm going to go node store blob. Hit that. Wow. Okay. Right. So first log line is that CID. So the CID for this this is yes. Hello, this is dog, butcher. And then the second one is the status object that we queried for. So we get the CID back again. This second property is the deals, the Filecoin deals that this particular CID is included in. Now, one thing to note is that usually you will see, like as soon as you upload something, this will not be populated. This is something that I've actually uploaded a while ago, and so it's had a chance to make it into Filecoin deals, which is why I'm showing you this particular item. But here we go. We've got Filecoin deals. So we've got 3 deals here, and these deals have been done on mainnet, Filecoin mainnet. This is the miner that this deal was made with, the current status. So initially, when you upload stuff, you'll get an object with status maybe queued to say that it's being queued up. And what kind of is interesting is that we're kind of batching up this data in it, so it will be queued up, and then eventually we'll make a big deal with the miner with lots of data. So that's the deals. I don't know if there's anything more interested in there. We've got the network in there because we have test nets, and then it allows us to make deals with miners that are running crazy experiments and stuff on different networks. So we also get the size of the thing. We get the pin status, and yeah, that's the status API. But this is like the simplest, most simplest API we have. And actually, if you've ever kind of minted NFTs before, you'll know that an NFT, you actually kind of want both the asset, so the thing that's being minted, like the thing that the artist has created, or whatever it is that's being minted, but also you kind of need a metadata JSON file. So you'll need to store on IPFS kind of at least 2 things. So the asset as well as the metadata.json. And what that would mean, if you're using the store blob API, you'd have to do 2 calls. You'd have to do them sequentially, because typically from the metadata JSON file, you want to reference the asset, and you can only do that by having the CID of the asset. So you need to upload it first and then upload it. And it's just it just gets a bit complicated. So we have this. We have a metadata API which allows you to more easily create a metadata.json file from some data. So what I'm going to do is, okay, I'm going to try and do some proper live coding, and so we're going to do store. I'm going to create store metadata.js. Okay. So I'm just copying over the exact code we had in the previous example. I'm going to close up there. We're actually just make it smaller. We've got our yes, this is dog, and so our metadata API, what we call is we call a store function, and that we have some, obviously we have some TypeScript types for this, so we get some really good information about this function that we are adding. And so you pass that a object, and that object is what this kind of the JS form of your metadata, your typical metadata.json file that you would create when minting an NFT. So we're going to give it a name. We're going to call it if I could type properly. Yes, this is dog meme. I'm going to call it, yes, this is dog. And then we'll have a description as well. There we go. And then I think the minimum you can have is these items. And so I'm going to pass it a file, because what the API does is it checks that the data you're giving it is actually the image has to be an image or a video. So what we're going to do here is we're just going to say pass the file name in for creating a new file. So I can choose, so I can read this file with this file name, but I can call it whatever I like in the file. So that's cool, and that will be persisted. I'm just going to give it a type image JPEG, so JPEG, and then once I've stored that, let's get rid of this. we get back our metadata. And what we'll do is just log out the metadata.url. And this is the URL to the metadata JSON file that we created. So what happens behind the scenes is that the store method takes this object, and where we put actual file or blob objects in properties, what it does is it will do one-shot requests to nft.storage, and nft.storage will unpack that information. It will store all of the files and send you back basically a JSON object like this, but with these files replaced with IPFS URLs to that content which is stored on IPFS and Filecoin. So here we go. So I'm going to log out the metadata.url. I'll also log out the metadata.data. This is the actual data that you would typically see in a metadata JSON file, just to show that that URL, that file to URL conversion. But this metadata.url property is basically what you'd store when you're minting your NFT. So here we go. Whoa. Save that. Let's give this a go. Hopefully, with any luck, this will work first time. Oof. Okay, rad. Okay, so we've logged out this the URL. This is what you'd see, what you'd store on chain, and this references this. Well, this is a JavaScript version. We've got like, but this is a URL object. But if you toString on that URL object, then you get this string here. And so what we'll do now is we'll just log out. Let's log it. Actually, let's just log out. We've got an embed function, and what this function does is it gives us back that same object here, but instead of having URLs that are just the IPFS URLs, this will actually replace those with IPFS gateway URLs. So it will typically be a dweb.link URL. So let's just rerun that to get those gateway URLs. Here we go. And so this becomes clickable. I can just open this, and it should open in my browser. Hooray! And that's my dog. Rad. I should also be able to, if I grab this, I should hopefully be able to go. So another gateway, different. It's the same but different. You should be able to fetch content from IPFS from any HTTP gateway. So it doesn't matter which one you're using. And this is my JSON file. This is what was created for me. So super rad. All right. I think that's about it for the live coding. I can't believe it all totally worked. Right. Let's stop share for a second, and we'll head on back to the slides. Cool. So aside from nft.storage, there's some other things I wanted to just quickly tell you about, if I have time. So we're going to be starting our Save the NFTs initiative, and what that means is we're going to crawl the Ethereum chain from Genesis. Well, I don't suppose there'll be too many NFTs at Genesis, but you get the idea. And what we're going to do is we're going to upload all of the NFTs we find to nft.storage. So none of these NFTs that have been created so far, like none of them will hopefully ever like disappear off the internet again. We'll upload stuff that's IPFS already, but also things that are on the end of URLs to things that aren't IPFS or decentralized at all. So we'll do that, and we'll do it for not just Ethereum. We're also going to see if we can save NFTs on other blockchains. And of course, what we'll do is we'll try and visualize that data on nft.storage. We're going to create a new NFT checker. There's already an NFT checker, but this would be a new one, and it will show you the health of your NFT in terms of like how many providers on IPFS there are for your NFT, and how many. And obviously, it will show you that information that I've already showed you about the Filecoin deals that your NFT is on. So how well stored is your NFT, I guess, in the long term. And obviously, we'll try and make those metrics available to developers over some sort of public API, so they can do what they please with it. The second and final thing before I leave is about this brand new website. And so storing NFT data, the off-chain stuff, is just like a very small part of a much bigger process of actually minting an NFT. And so if you actually want to do something like that, and you have no idea what you're doing, like me, then this brand new website should help you out with that. So it's got like step-by-step tutorials and how-tos and code samples and like references for the ERC schemas and stuff, and like the concept of DApps in general and stuff like that. So and the best thing is that all the tutorials here actually use nft.storage, so you get all of those good practices all kind of baked in. So you should check this out. This is brand new. This was launched like yesterday. So there's some stuff that's still under construction. It's completely new, but you should go check it out. And please, any feedback you have on it is greatly appreciated. So that is all of the words that I have to say for now. You should go and check out nft.storage and nftschool.dev. That's the school that I just talked about. But yeah, thank you very much.
For NFT storage, is the metadata fully immutable, or can that be amended over time if you were to add more properties? And just the question is around just that, and there are a couple of other threads around it, but maybe this is a quick answer.
Yeah, this is a conversation we've had previously, and right now there is no mutability. IPFS in general is not great for mutability for the reasons that I mentioned earlier, but yeah, we've been having conversations, and we want to kind of come up and build this thing out. And well, I'm not sure how necessarily how that would work for metadata, adding properties to that, but in general, like having kind of IPFS collections of things would be really useful, and we're trying to build that out now. But yeah, no, not at the moment.